So now I will explain the part of the system where object-oriented programming is used. First is inheritance. The user class is used to represent the basic data of an account. However, the information required differ depending on the user's role. For this reason, child classes such as student were created to extend the user class and store role-specified data. Next is polymorphism. The user class has three child classes: student, admin, and officer. Each role has its own specified field, so the data written to the user account file differ when update data or creating a new account. Therefore, method overriding is used to return role specified data based on the actual user type. The next component is encapsulation. Data such as the current logged in user and the user data begin processed are protected so that they cannot be modified directly from outside the class. By encapsulating those fields and controlling access method, unintended data modification can be prevented. Finally, abstract is used since menu behavior and display component differ depending on the user's role. Common behavior is different in the user class, and the specified implementation is different in each child class. This allows the system to display different menus screen according to the user's role. That concluded my explanation of how OOP is used in this system.
Hello, Madam. My name is Yulia, and I'm going to explain the OOP concept and the logic applied in my code. So I will explain the OOP concept first. So here are the OOP concept I used. We have the inheritance, encapsulation, polymorphism, and also the abstraction. For the inheritance, you can see here, the keyword is extends. So I already inherit the JFrame. That means I don't need to create the window, resize the window manually, because it already inherits the behavior from the standard Java string class JFrame, from the standard Java string class JFrame. And for the encapsulation, here is private list, field student, filter students. So I use the private class modifier for my fields, and so other class cannot directly mess with my filter student list. And third one is the polymorphism. So here inside my default table, I overrode the is still editable and get column class methods. So editable. So I make the third column become Boolean, because later I want to do the checkbox. Then other remains the string class. So if the column is the third one, then it can be editable. So the standard table model treats everything as a string and editable, and I'm used polymorphism to tell the table these specific interns behave differently. And the last one is the abstraction. So let's back to these LUT students here. So as you can see here, there's complex logic to read the file. But here in the constructor, I don't write all the CSV parsing logic. I just call them LUT students because they don't need to know how the field is read, only that it needs to be read. This makes the code readable and easier to debug. That's all the OOP concept I used.
Hello, my name is Aiden Gokunzi, and today I'll be demonstrating the eligibility check and enrollment part of our course recovery plan system for Java. I will be running I'll first show you the output for the eligibility check. So in this window, you'll be able to see the list of ineligible students who do not meet the requirements to continue on to the next level. Here there's a table that lists all who are not eligible, as you can see here. Of a specific student. For example, let's search for this Bob Smith. So see, by typing Bob in the search bar, you can search it, and by double clicking this row, another window pop up. This shows the student details for here you can see the ID, the name, the major, the year, the email, and the overall CGPA, and the total number of failed courses. Below here, there's a table that shows the courses that the student has failed, like this. It displays the course ID and the attempt number, the exam, the assignment grades, and the GPA for that course, and the components. So next is I'd like to talk about the OOP concepts. So right now, let's talk about encapsulation. So right now, most of the data are being processed, for example, in this student data manager class here, where you can confidence with the criteria of the GPA must be more than 2.0 to be eligible, and there's the grade calculation, the weight, and the credit hours of extracting, and the grade point conversion. All are encapsulated in this data manager class for calculations. And abstraction is defined where the student data manager class is an object called data manager is created from the data manager class to be called in this load students from file function method, where the load ineligible students method in the data manager is called to populate the ineligible students table for display. And the abstraction is shown in here because the load ineligible students method is not shown. It's only called without any operations or processing logic being explained or written in this file from another class. Polymorphism is also demonstrated in this override method, where the mouse event is changed to a double click check listener. when a row is double clicked, then it will open up the new details frame that shows an object, initialize it with the data to display the specific students. And for inheritance, this class is a child class of the JFrame file, as it.
Hi, so my name is Ian Akish bin Abdulaziz and my TP number is TP086043, and today I would like to talk about my part of the code for Java and also the concepts that I use and the logic flow. So now I'll be sharing my screen of my code. So as you can see here, this is my code. So as you can see here, this is my code, academic performance reporting.java. And first of all, for my OOP concept, the first one that I use is encapsulation, where I store all my student, course, and report data inside separate classes. So for example, like this one, field students, student information, and courses I installed in a separate classes. Now for the second one is abstraction, which the CVS file handling is hidden using methods like read CVS data, where which one, yeah, this one, student read CVS data. Also yeah, and for the third one is object composition, where report item, sorry, let me try to find the report item. Yeah, so this is my abstraction, student information dot read CVS data, fail underscore students dot read CVS data, and course information dot read underscore CVS data. And report item, yeah, this is my report item, combines the student, course, and fail attempt information. This is my report item, where this is my object composition. And for the fourth one is polymorphism, which I use it Java library classes, which uses the default table model, the PDF PT table with common methods. So let me try to find it. Sorry. Yeah, this one. This is my polymorphism. This is my and the last one is separation of concept, where I separate my UI data processing and my PDF generations are handled in different classes method. So yeah, so this is my academic performance reporting Java, and this is where they generate the PDF report. And now I will be talking about the program logic, which is the workflow. So first of all, the load student data, which is this one, the load student data and display available years in the combo box. And second is filter students by selected year and show them in a table, where this one, table, show them in a table. And then program read student, course, and failed course CVS files, where this this one, they read from the CVS, and after that the program reads after that the matching data is combined into report items object, which is this one, and the PDF academic performance report is generated, which is this one. This is the table where you can see all the ID name and major, and this is where you will get the final report. It will print out the final report size and it will print out generate PDF report. So I think that's all for my part. So thank you and have a good day.